Hi, I'm Shyamala Gauri, Assistant Professor in Rohini College of Engineering and Technology. Subject code CS3301 Data Structures. Unit 3 Trees. I'm going to explain priority queue and binary heaps in this presentation. Priority queue. Priority queue is more specialized data structure than queue. In priority queue, items are ordered by the key value so that item with the lowest value of key is at front and item with the highest value of key is at rear or vice versa. So we are assigned priority to item based on its key value. Lower the value, higher the priority. The basic operations of priority queue are insert or enqueue. It adds an item to the rear end of the queue. Second is remove or dequeue. It removes an item from the front end of the queue. This is the representation. This is the representation of a priority is shown below. Priority queue is shown below. Insertion will be done at the rear end of the queue, and deletion, removing an element from the queue, is done at the front end of the queue. Insert or enqueue operation. Whenever an element is inserted into queue, priority queue inserts the item according to its order. Here we are assuming that the data with high value has low priority. For example, here 15, the element 15 is inserted. It has to be inserted in the rear end and pointer is pointing to the newly inserted element 15. Next operation is remove or dequeue operation. Whenever an element is to be removed from queue, queue get the element using item count. Once element is removed, item count is reduced by 1. See, here at the front end, the pointer is pointing to the value 3. So if 3 is deleted, the pointer is moving to the previous element and the item count will be reduced by 1. Next topic is binary heap. A binary heap is a complete binary tree which is used to store data efficiently to get the min and max element based on its structure. A binary heap is either min heap or max heap. In a min binary heap, the key at the root must be minimum among all keys present in binary heap. In a max binary heap, the key at the root must be maximum among all keys present in binary heap. To add an element to a heap, we can perform this algorithm. Add the element to the bottom level of the heap at the leftmost open space. Compare the added element with its parent. If they are in correct order, stop. If not, swap the element with its parent and return to the previous step. Steps 2 and 3, which restore the heap property by comparing and possibly swapping a node with its parent, are called the upheap operation. It is also known as bubble up, percolate up, shift up, trickle up, swim up, heapify up, or cascade up operations. Insert operation example. Say we have a max heap here and we want to add the number 15 to the heap. We first place the 15 in the position marked by X. However, the heap property is violated since 15 is greater than 8. So we need to swap the 15 and 8. So we have the heap looking as follows after the first swap. 15 is swapped. 15 and 8 are swapped their places. However, the heap property is still violated since 15 greater than 11. So we need to swap again. Here now the values 15 and 11 are swapped, exchanged their positions, which is a valid max heap. There is no need to check the left child after this final step. At the start, the max heap was valid, meaning the root was already greater than its left child. So, replacing the root with an even greater value will maintain the property that each node is greater than its children. Next one is extract operation in binary heap. The steps to be followed to delete an element from heap as follows. Replace the root of the heap with the last element on the last level. Compare the new root with its children. If they are in correct order, stop. If not, swap the element with one of its children and return to the previous step. Swap with its smaller child in a min heap and its larger child in a max heap. Steps 2 and 3, which restore the heap property by comparing and possibly swapping a node with one of its children, are called the down heap. It is also known as bubble down, percolate down, shift down, sink down, trickle down, heapify down, cascade down, extract min or extract max, or simply heapify operation. Here is an example for extract operation. So this is the given max heap. First extract 11 from the max heap. If we remove 11, we have to replace it with 4. Now the heap property is violated since 8 is greater than 4. In this case, swapping the two numbers 4 and 8 is enough to restore the heap property, and we need to swap elements further. The downward moving node is swapped with the larger of its children in a max heap. In a min heap, it would be swapped with its smaller child until it satisfies the heap property in its new position. This functionality is achieved by the max heapify function. Thank you.